Rocks and minerals are all around us. They tell stories and reveal many things about the Earth's eventful past. In your backyard or at your local beach, you may find rocks that are unique to your region and hold a piece of the past. Today, we're going to be examining rocks and minerals from this collection here. This one's just an example. Yours might look a bit different. The first thing we notice when opening the lid is an assortment of unique rocks and minerals. You're probably curious about these contents and are wondering where to start. Well, that's where these come in handy. Each kit comes with a list of your rocks and minerals, as well as an introductory study guide with some descriptions and properties of the box's contents. Now, rocks and minerals have their own properties, and there are questions we can ask and tools we can use to help us find out more about them. You may have already noticed the unique colors of these specimens, but it's important to not judge them by their color, because oftentimes the color we detect with our eye is not the same as the actual color of the minerals that make up these samples. Let's take a look at an example together. Before we begin, it's important to know the difference between a rock and a mineral. A mineral is a naturally occurring solid that is made up of inorganic compounds and has a unique crystalline structure. A rock is made up of minerals. Here I have a piece of calcite that appears to be light green in color. Now, will the color we observe with our eyes match with its streak color? Let's find that out using a streak plate. A streak plate is an unglazed piece of porcelain that is either black or white. It helps us determine the color of minerals in powdered form. For this, let's use the black streak plate and scrape it along the plate. So the color of the streak is actually white and not green. Let's look at another example. Here I have pyrite, and it is golden and shiny. Let's use the white plate this time. And the mineral color it gives off is actually black. So see how the color we observe with our eyes might not always match up with the color of the streaks. Another thing you may observe in certain rocks is their grain or crystal size. Igneous rocks, rocks that form via cooling and solidification of magma or lava, usually have visible grains in them. Ones with smaller grain sizes signify faster cooling, resulting in less time to form larger crystals. This formation usually happens above the Earth's surface where it is cooler. Rocks with larger grain sizes have more time to cool and form crystals, and this usually happens under the Earth's surface where it is warmer. Let's take a closer look at some igneous rocks using a magnifying glass. On this side, we have a piece of granite. Notice the crystal size. And here, we have some trachyte. And notice its grain size. As the granite has smaller crystals, this probably means it cooled faster above the Earth's surface, and this one cooled beneath the Earth's surface. Today we've explored two properties of rocks and minerals, but there is still so much more to discover. Once you've familiarized yourself with a few more properties such as magnetism or hardness, feel free to start categorizing these rocks and minerals in groups based on similarities and differences. This demo here ties in well with Activity 2, Classify This, from the Geology Toolkit. While a collection like this is not necessary for learning geology, it can definitely enrich your learning experience. In the meantime, keep an eye out for rocks and minerals that exist all around us in nature.